Hello everyone, in the last video we discussed about the concept of stride. If you guys remember, given an image of 6x6 and kernel of size 3x3 and the number of kernels can be m, in that case the output shape will be whenever stride equal to 1, it is coming up to be 4x4x m, and whenever stride equal to 2, it is coming to be 2x2x m. Okay, 1, 2, 3, 4, 5, 6, right? So there are 6 columns. Stride equal to 1, first we'll be covering these 3 columns, and after covering 3 columns, as the stride is 1, we'll start from second column itself. We'll just move by 1 column and we cover these 2, 3, 4 columns, and after covering 2, 3, 4 columns, we'll start from third column, and similarly we'll cover 3, 4, 5 columns, and after covering all the 3, 4, 5 columns, then we'll start from fourth column and we'll cover 4, 5, 6 columns as well. So like this, total we'll be getting, if you observe, this is 1, 2, 3, 4. We'll be getting 4 outputs for the first 3 rows, and similarly we'll be getting 4 outputs over here also. Column wise and row wise, completely we'll be getting 4 outputs. Okay, so that's why the output shape will be 4x4. And similarly, when stride equal to 2, the same operation will happen, but instead of moving by 1 column or 1 row, we'll be moving it by 2 columns, okay, or 2 rows. So in that case, first we'll be covering this 1, 2, 3, and after covering this 1, 2, 3 columns, then we'll start from third column. So 3, 4, 5 will get covered, and after covering this 3, 4, 5, we need to start it from fifth column. But if you start from 5, then you will not be able to cover the whole 3 columns, that is 5, 6, and 7, because 7th column is not present. So that is the reason we'll stop process at this point itself, and again we'll start from the third row, that is 1, 2, 3. So from this row we'll start the process again. So when we start from this, we can cover till 5. So that is 3, 4, and 5. And after covering these 3, 4, 5 rows, then again we need to start from 5th row. But from 5th row, if you can start, you can't go till 7th row, as you need 3 rows. As you are not able to cover 7th row as well, you'll stop then and there itself. So that's why the output shape will be 2x2. While we are doing this, there is a problem that we might not cover this row and this particular column. So this is the problem that is occurring with higher stride, right? So let's try to see how to eliminate this particular problem. So in order to eliminate this problem, I said there is a concept called as padding. Now let's discuss how padding works. Basically in padding, what we'll be doing is, there are several strategies for padding as well, but one of the most famous strategy of padding is zero padding. In zero padding, what we'll be doing, we'll be adding zeros on all the sides. That is, we'll be adding zeros over here, and also we'll be adding zeros over here, and also we'll be having zeros over here, and similarly we'll be adding zeros over here. So like that, as we have added zeros on all the sides, the input shape will become 8x8 now. So previously it is 6x6, but now the input shape becomes 8x8 because it is increased by 2 rows and 2 columns, if you carefully observe. So this is one extra column, and this is another extra column, and similarly this is one extra row, and this is another extra row, right? So that's why now the input shape will be 8x8, and on this input shape, that is 8x8 input shape, what we'll be doing, we'll be applying the same operation. Now let's say stride is equal to 2, then let's see how we'll be getting the output. 2, 3, 4, 5, 6, 7, 8. First, as the kernel and filter size is 3x3, we'll be covering the first 3 columns, and after covering the first 3 columns, then as the stride is 2, then we'll be moving by 2 columns, right? So we'll again start the process from 3 till 5. Once we have gone till 5, then again we'll start from 5, right? From 3 we need to move by 2 columns, that is from 5. So once we start from 5, then we can go till 7. After going till 7, then again we need to start from 7, but from 7 we can't cover another 3 columns, right? If you see, from 7 you can't go till 9, because ninth column is not there. But if we carefully observe, here we are covering this part completely. So this portion is getting covered. And also, if you observe, this portion is also getting covered, these zeros also. But the main important thing that we need to observe over here is we are able to cover all the input feature map that we wanted to get covered, right? All this complete input feature map is getting covered. As it is getting covered, we don't care whether this extra portion is getting covered or not. It is just zeros. So we clearly know that there is no important information in this portion, right? So even this is getting covered or not, we don't care that much. But the important thing that we need to observe here is the input feature map, that is this portion. The input feature map is this portion, right? This portion is exactly getting covered. This is what we are interested in, right? According to this, what will be the output shape when stride is 2 and padding equal to 1? If padding equal to 1, what will happen? Our input shape will become 8 cross 8. Okay. On 6 cross 6, if we apply padding of 1, then we'll be adding zeros on all the sides, which will make our input shape to be 8 cross 8. And on this 8 cross 8, we'll be applying the same operation that like when stride equal to 2 over here. Whatever operation we have applied on 6 cross 6, the same thing we'll be applying it on 8 cross 8. And then the output shape that we'll be getting will be 3 cross 3 cross M. In that way, we'll be able to get overall in lesser size, and also we'll be able to cover whole of the input portion. I hope the concept of zero padding is clear for everyone. Now let's see how the input and output dimensions will change in case of formulas. Then you'll understand it better. Basically, in convolution, we'll be having an input shape of n cross n, and we might be having a kernel of size k cross k. And what will happen to the output shape? When there are m such kernels, by default, the stride will be 1. Then the output shape will be n minus k plus 1 cross n minus k plus 1 cross m. Okay. So like this, my output shape will be changing. And let's say if stride is 2, then if you observe, almost it is dividing this with the s, right? So this is what is happening if you carefully observe. Okay. As we are almost observing even shapes, this is correctly coming up to be by s. But in general, if we carefully observe over some number of examples, then this will be the correct formula, that is n minus k by s plus 1 cross n minus k by s plus 1 cross m. So when stride is s, this will be my output shape. If you take input shape to be 6 and the kernel size to be 3, then 6 minus 3 by 2, that is 3 by 2. So 3 by 2 lower bound will be 1 because it is 1.5. 1 plus 1 will be 2. Like that, every time we'll be getting the correct shape, that is, it will be 2 cross 2 cross m whenever stride is 2. If you are making it to be 8, 8 minus 3 will be 5. So 5 by 2 will be 2. Lower bound will be 2. 2 plus 1 will be 3. Like that, we'll be getting the correct shape every time. So use this formula whenever you wanted to calculate the output shape. And this is when stride is S and input shape is n cross n and kernel size is k cross k. But it can happen that we will be having padding also. Let's say padding is 1. If padding is 1, what will happen to the input shape? If you carefully observe, previously my input shape is 6 cross 6. On applying padding of 1, it is becoming 8 cross 8, right? So if you apply padding equal to 2, then another another row and column of zeros will get added like this. On adding these, then my input shape will become 10 cross 10. That means that whenever my input shape is n cross n and padding of p, then what will happen to my input shape? My new input shape will be n plus 2p cross n plus 2p. I hope this is understandable, because for each padding, we are adding an extra row and column of zeros. Okay. So that is why it is increasing the input shape by 2 every time. So I hope this is clear. Once the input shape becomes like this, then the formula remains the same. that is, now this is our input shape, that is n plus 2p cross n plus 2p, and stride is s, and kernel size is k cross k. So the updated formula will look something like this: n minus k plus 2p by s plus 1 cross n minus k plus 2p by s plus 1 cross m. Like that, my output shape will change according to the stride and padding. Okay, so the same formulas can be applicable in case of pooling as well. What will happen? Is there any kernel or filter in case of pooling? If you guys remember, like there is no such kernel or filter. There will be having window size. So if the window size is s, then what will happen to the stride? The stride will also be s, right? So there also we can use the concept of padding. Whenever the window size is s, by default the stride will be s and padding equal to p. So in that case, how my output shape will change? It will be n minus, so instead of kernel, we are having the window size of s cross s. So instead of k, you need to replace it with s. So n minus s plus 2p by s plus 1, and similarly n minus s plus 2p by s plus 1 cross m. That my output shape we can calculate in case of pooling as well. In case of ReLU, there is no change in input and output shape, but in case of either pooling or in case of convolution, there is a slight change in input and output. With these formulas, I hope that you will be able to calculate easily how input and output shape is getting changed. Okay. In the next video, we'll see the overview of CNN till this pooling layer. Or first we'll discuss about fully connected layers, and then we'll see the overview once again. Then it will be very clear for you how CNN is working in everything. Okay, that's it for this video. If you have any doubts, please comment down in the comment section. Thank you everyone. Bye bye.